All right, this is our third and final day on U substitution. So if you want to title your notes, again, title it U substitution. But specifically today, we're going to focus on U substitution with ln x, e to the x, and some trig, specifically cosine and sine. All right, let's go ahead and tackle this problem. Make sure you have it down. This is a little trickier when it comes to choosing what my u is. However, it's almost always going to be the case that if you see a natural log in your u substitution problem, you're just going to let your u equal ln x. And I'll tell you why in a second. When we take the derivative du, we get 1 over x dx. And if I just put a 1 here, which I can, because that doesn't change the problem, notice how I actually have a 1 over x dx. And so that's already in the problem. And that's why I do that, because almost always when you see a natural log in the problem, it's the case that when you take the derivative of it, that 1 over x shows up in the problem. First thing I'm going to do here when I attack this problem is get rid of this 5. So that's pulling out a 1/5. And now I have cosine of ln x over x dx. And just for the sake of it, I'm going to put a 1 right here. All right, now let's go ahead and find some matches. So this 1 over x dx is going to become 1 over x dx is going to become du. So this becomes du. And then I have cosine of ln x, which means I'm actually going to have cosine of u. And then don't forget my integral of 1/5. All right, integrating this, I know I get sine of u plus c, and then I'm going to throw my 1/5 back in there. Because remember, the derivative of sine is cosine. And my last step, just like we're used to, is going to be to plug back in that u value. So I'm going to have 1/5 sine of ln x plus c. All right, let's go ahead and tackle the next one. On this particular problem, it's kind of fun because you can choose either sine or cosine to be u. It actually doesn't matter. First step, though, is I'm going to pull out that 5, and you can always pull out the constant, and it just doesn't change the problem as long as you remember to add it back in at the end. So my u, in this case, I could choose sine or cosine, but I'm actually going to choose sine x. And the reason why is because I'm going to get a perfect match. If I take the derivative of sine, of course, I get cosine. And what's nice is I have this perfect match right here. We can see it right here as well. So this is going to be 5 integral. This whole box thing here becomes du. See that? And then my sine of x is actually just u. So this is going to be the integral of u du with that 5 out in front. You can think of that as u to the first. So when we integrate that, we add 1, we get a 2, we divide by 2, and then don't forget to put that 5 back in. Last step, of course, is going to be to substitute my u back into the equation in terms of x. So this is going to be 5 parentheses sine x squared over 2 plus c. There we go. And if you want, you could go ahead and rewrite sine x quantity squared. You can rewrite that as sine squared x. Those are the same exact thing. All right, example 12, we are going to try a problem with e raised to the power of something. In this case, the only thing we know how to take the integral of is going to be e to the x. And so that means that we need to rewrite this problem so it's just e to the x or e to the u. So we have to, in a problem like this, just choose our u to be whatever e is being raised to. And I'll reconnect what I was just saying in a second once we're ready to do this. So set your u equal to a negative sine x. the derivative of that is a negative cosine x dx. All right, first thing I'll do here is take my 3 out. It's bothering me. So it's going to be 3 integral of e to the negative sine x cosine x dx. Now, I want to have a negative cosine x dx here. See how I want to get that match? So I need to put a negative here, which means I also put a negative here. Because negative times a negative, it would be a positive 1. So we're not changing the problem. Okay, now we have our perfect match. So we've got our negative cosine x dx, and that whole thing is going to become a du. Okay, now this next thing here is going to be e to the negative sine x. Well, remember, we let negative sine x be our u, so this is going to be e to the u. Now, if you're saying, hey, Miss Sorensen, where'd that negative go? Remember, that negative was attached to the cosine x dx to get that match here. All right, and don't forget to write your integral symbol with that negative 3 out in front. Okay, connecting now to what I said in the beginning here is that this is the only thing we know how to integrate with e, is e to the x or e to the u. And we know that the integral of that is just a plain old e to the u, because the derivative of e to the x is just e to the x. So this is going to be e to the u, don't forget my minus 3 out in front, and then plus c. And our last step is going to be to substitute in our u values, so we get negative 3 e to the minus sine x, and then a plus c. That's it. We're done with that one. Alrighty. We've got one more. I think I should have titled that number 13. Now, in this case, we already have an e to the x, and so we don't need to set our u equal to whatever that raised power thing is. Like, for example, here the raised thing was raised to the negative sine x. That's not the case here. So you might be tricked a little bit with this problem, where I was saying before, you need to set it equal to this thing. Well, because it's just e to the x, we can go ahead and just let u equal e to the x. The derivative of that is going to be e to the x dx. So I'm ready to go ahead and start this problem, but first I'm going to pull that 4 out. So I've got 4 integral e to the x cosine e to the x dx. And now we have tons of matches here. First of all, we have a match with our e to the x dx. Not perfectly in the right order, but there's the match right there. So that whole thing becomes a du. Now we've got to deal with this cosine of e to the x, which is just going to be cosine. Remember, my e to the x is u, so it's going to be cosine u. And I'm going to remember to put my 4 out in front. Now, integrating that is going to give me a 4 sine of u plus c. Just check that is the derivative of sine cosine. Yes, it is. Substituting back into that problem, I get 4 sine e to the x plus c. So in a problem where you have just plain old e to the x, you don't necessarily have to set your u equal to whatever the power is. Like in this case, that was my hint that you almost always do that. But like I said, in this problem here, it's just plain old e to the x, so you don't have to do that in this case. All right, folks, hope you enjoyed it. These are certainly harder problems, and this is our last day. Thanks for watching.